Okay guys, let's take a look at number 2 on the test here. Given this problem here, we have some parallel lines. So again, one thing I've been asking you guys to do, and I need to do a better job at actually just re-showing and re-showing. Anyways, when we talk about parallel lines, we need to talk about angle pairs that are congruent. So this picture here shows our 3 congruent angle pairs. So when lines are parallel, remember alternate interior, so this purple and this purple, these 2 alternate interior angles are congruent to each other. That's a relationship that's always true. And then these darker, bigger, obtuse angles here are also alternate interior. We have alternate exterior angles, right? So angles like these 2 pink ones that are on the exterior, the lines on the outside and alternate sides of the transversal, they're always congruent when lines are parallel. Same as these blue ones, they're just the supplementary angle to the pink one, right? Because they add up to 180. So these angles are congruent as well. And then corresponding angles, there's actually 4 pairs of congruent angles. So pink is congruent to pink, purple to purple, this dark kind of purple to black color, and then the blue ones, those are corresponding. They're always going to be congruent. And then the 4th pair that we always talk about when lines are parallel, same side interior angles like this blue one and this red one, right? They add up to 180, therefore they're supplementary. And that'll always be true when we're dealing with parallel lines. So when we talk about proving lines being parallel or using the fact that lines are parallel, we have to think about these 4 angle pairs, and some of them apply in a picture, some don't. So in this picture, let's just do some thinking and talking, and then we're going to prove this together. So here's our problem in GeoGebra here. Okay, so first of all, let's take a look at some. I'm going to hide this problem here. I'm going to take some lines. Okay, so here's a pair of parallel lines. This red line here is what we call a transversal. It's just a line that's intersecting both parallel lines here. And notice that we have some alternate interior angles that are going to be congruent. So no matter what our transversal looks like, or whatever relationship, those alternate interior angles are always going to be the same, right? So no matter what this looks like. So let's put that problem on this picture here. Actually, before I do that, let's just move this around a little bit more just to kind of show that no matter what, as long as we have parallel lines, remember that these alternate interior angles are going to be equal, 132.4 degrees to 132.4 degrees. The purple angle is supplementary to the green one, right? Because they add up to 180, they're a linear pair. So that is 47.6 degrees, and so is this other purple one, this other alternate interior. Okay, so now, if we look back at this problem here, I'm going to take those lines, and I'm going to put it on top of our picture here. So I'm going to move A to this corner. So these purple points that are my points that make my parallel lines, I'm just going to move them. Okay, so now we've got our lines that are parallel, and I'm going to move my red line so that it's this transversal here. And notice where is my, oops, something's kind of weird here with the angles. There we go. Okay, sorry about that, but if I move my points here on the vertices, you can see that those alternate interior angles that we have here, right, on these parallel lines, they're going to be congruent to each other. So if you think about these 2 triangles, this is what we're trying to prove to be congruent here. Remember that we're trying to show that a corresponding congruence combination exists that we know. And here's one that we know because we have parallel lines, and we're keeping in mind this alternate interior relationship that when lines are parallel, those two angles are congruent to each other, then that means that in these two triangles here that we have here, this lower one and this upper one, that they share this angle in common. That's congruent in both triangles, right? So with parallel lines, we just say that they're alternate interior angles, and they have to be congruent because these two sides are parallel, okay? And kind of interestingly too, if I switch the diagonal, so I just put this red one on here, notice it's the other, that supplementary angle, right? That supplementary angle to green. Now it's that angle pair, but notice they're the exact same thing, right? They're congruent to each other because these lines are parallel. So it doesn't matter which angle pair we talk about. Notice as we draw this diagonal in here, now we're talking about this upper triangle and this lower one, but it's still the same. These are going to be congruent to each other, right? Okay, so now what we have here is we've got this fact that because the lines are parallel, those alternate interior angles are congruent to each other. Okay, but also we have the fact that angle R and angle P are right angles, right? So I'm going to put these on there a little better. There we go. Dang it, I just want E. Okay, so now to prove that, or given that we have the fact that angle R and angle P are right angles, that means that, you know, we got these 90-degree angles here, right? So if I use my perpendicular line tool and I click on this parallel line, for example, and I click on this point, notice that perpendicular tool makes a 90-degree angle, so that angle is, because it goes through this other point now, that truly is 90 degrees. And we're also given that this angle is 90 degrees. So if I go perpendicular to this side through point R, notice it goes through our other point there. So given this fact that we have this perpendicular angle going on in both triangles, not only now do we have that this angle and this angle are congruent, but we also know that these 90-degree angles are congruent. Okay, so geometrically, this is really the relationship that we have going on here, right? We have those parallel lines. We've got these angles being congruent here due to the parallel lines in this diagonal. And then we have the fact that we had the 90 degrees, so maybe we'll make those, say, purple. So, I must have grabbed the wrong point there. Sorry, I'll try to measure those again. Maybe I'll hide E for a second. Well, sorry, I got some problems going here, but those are supposed to be 90 degrees. So to keep this thing moving here, those are 90 degrees, so my bad. But we have an angle and an angle, right? And notice now both these triangles share this diagonal section right here, right? So we have a side congruence too. So we have this angle, angle, and a side that's not between the two angles. So we have what we call an angle, angle, side situation here, right? So that's what's going on in our picture. So we know we have enough to state that this triangle has to be congruent to this triangle, and not only that, but their parts, like this angle here and this angle up here, the other alternate interior pair here, due to the fact now that these green lines have to be parallel. So this is a rectangle, so it's also a parallelogram too. So now let's go ahead and talk about the proof. So the proof is just writing what we're talking about here and what we're discussing here. So the first thing that we discussed in this problem was our given information. We had angle, well, second thing I guess, but angle R and angle P are right angles. So I'm going to hide these lines here. Okay, so R and P are right angles, right? That 90 degrees, you can kind of see those right there. It's supposed to be 90 degrees on both of those, but we're given those are right angles. Okay, we're also given the sides Q and R, the blue side, and P and S are parallel, right? QR and SP, they're parallel to each other. We were given that. Okay, so the fact that we have those parallel lines and we have this diagonal being like a transversal, these two angles, these alternate interior angles, are congruent. So we have a theorem, we have a proven statement that we actually proved in class that says when lines are parallel, then the alternate interior angles are congruent, and that's what this theorem says, so that's our argument. So we know that this angle SQR, right, so this angle SQR right here is congruent to this angle here. So we have the fact that angle P and angle R, I'm just going to state the fact that they're congruent, because our proof has to, guys, if we're going to use like a side or a side angle side or an angle side like in this case, in our proof, before we make that statement, we have to have it stated with logical reasoning that we have each congruence combination in sides and angles before we just state the two triangles have to be congruent. We have to make the fact that they have the three parts in the combinations being congruent. So here we have this angle SQR, those alternate interior angles. We're stating that they have to be congruent to each other. We're also stating because R and P are both right angles, that means that they have 90-degree measures, right? So they have to be congruent to each other. And I just wrote here for our reasoning, well, they're both right, so by definition of right angles, then they have to be the same measure, right? They're both the same thing. They're both 90 degrees. So now we have our second angle pair being congruent. So we have our angle mentioned, our second angle mentioned. So there's our angle. And then let's mention that side piece too, right? So we have the fact that both triangles share QS. So by the reflexive property, QS is congruent to itself. Okay, so now we have this angle. Oh, that didn't work, but we have this angle side mentioned, so now we can go ahead and say, well, what we wanted to prove here, right, in this proof, to prove that these two triangles are congruent, we have that angle, and the side mentioned in here with a reasoning to why it's congruent in both triangles, and therefore we've argued this angle side combination in these two triangles, which then force both of these two triangles to be the exact same thing. Therefore, these sides right here are going to be congruent because they're corresponding parts, right, of congruent triangles, so they're congruent, right? That's what CPCTC means. We didn't need it in this proof because we stopped at the fact that we proved two triangles congruent. And so to always argue that, the reasoning for that's always going to be a triangle congruency combination, right? If we wanted to talk about congruent parts now and corresponding parts, then we're going to use that CPCTC as our argument, just like in the next proof here. Okay? I hope that made sense, guys, and I hope well, yeah, I just hope that made sense, so I'm done.